Hello and welcome to episode 32 of the Primary Maths Podcast, the show where we talk all things maths. With me, John Cripwell.
And I'm Sally Cole.
Hi, Sally. You are
Hello.
not Becky again.
No, not Becky. Keep trying to be, but no.
No, but it is absolutely lovely to have you back. Thank you very much for stepping into Becky's shoes this week because she can't be with us. And so, really appreciate you last minute dropping everything and coming onto the podcast again. So thank you very much.
Very welcome. Nice to be here.
Good. And how are you?
Yeah, I'm good, thank you. Yeah, just been toddler swimming, so all fun.
Yeah, all good
And a busy week this week. We have. I'm going to get my plug in quickly. You know how I like to
Yeah,
get it in
please
every
do.
episode that I am in. Yeah, we launched the Maths App on iOS this week, so yeah, that's been very exciting.
So that's
Cumulation.
available now across all Apple products, is
All
it?
Apple devices,
iPads,
yeah.
iPhones. Yeah.
Yeah,
Awesome.
so before you can use the web app on any browser, so you can use it on tablets already, and so you can still use it on Android tablets. But yeah, this means that you can use it on phones as well. It works a lot better on phones if you use the iOS app. So yeah, reaching more
And
people.
if people are not familiar with the Maths app, and why wouldn't they be? But if, for some reason they've been living under a rock, just very quickly, an overview of the Twinkl Maths app.
Yeah, so the Maths app's really good for fluency practice. So we've got two areas to it. It's got the multiplication tables check in it, which is just like it's like a simulator of the government check. What's really good about it is though you can sort of change the pacing, so you can change the timer and the amount of questions, and you can also just apply those settings that we've got for SEND children, so you can see whether actually they need those settings in the real thing, which I think is really helpful. And then there's the skill safari area, which is you've got number, place, value, addition, subtraction, and multiplication and division, and just 5 games for each year group on the really core sort of things that they need to learn in each year. So yeah, really, really useful. A lot of it's hooked around the ready to progress criteria, those things that we know we need to sort of check off before the next year.
Yeah,
And it's just a way to practice those skills that just need that repeated sort of practice.
Yeah,
Plug
it's just a really nice, interactive, engaging way of practicing those core skills, as you say, alongside the other areas of maths that you might be doing.
and it gives full reporting as well, so you can see how they're doing.
Yeah, and that's available with a Twinkl subscription.
Yeah. So you've got 50 learner logins on a ultimate subscription. So if you have your full subscription, yeah, you can get your whole class on board on it.
Nice. We don't do too many plugs for Twinkl stuff on here, but I do think that the Maths app is well worth a look for anybody who just wants to get a little bit more fluency practice into, whether that's your own child at home or whether that's, a class full of children at school. Definitely worth having a little look into that. So, yeah, so you've been busy.
It's just /apps/maths. I know sometimes the search bar on the Twinkl website can send you off in different routes. So yeah,
Surely not.
/apps,
Surely not, Sally. Everything on Twinkl is very easy to find. But yeah, /app/maths. Excellent. Yeah. I've had a busy but productive week this week. So yesterday I was lucky enough to be facilitating on a skit program with some fantastic students in Nottingham. And we spent a whole day, Sally, 9 till very nearly 4 o'clock, just looking at multiplication and division. And we didn't actually finish the day. We've got to come back to division at the start of the next session because there was just so much to cover in that topic, really.
It's so nice to do that deep dive though, isn't it? I know when I did my NCCM specialist training, you go away for 2 days and you just talk about addition and subtraction or just talk about multiplication, division or fractions. And it's just, really immersed into it. But yeah, I think that's great for students.
It was really good. And every time I do that session, I think of something else as well, which, is really nice. And we talked about the MTC yesterday, obviously. And we also talked about the potential changes and what that might look like. and obviously we don't know yet, but with the curriculum and assessment review, it looks like there might be some minor changes to that, although the check is here to stay.
Hmm.
Um, and we also talked about sort of the purpose of the check and whether it is just to inform teachers or whether we think that there might be a slight, uh, ulterior motive in so much as it actually focuses schools on teaching multiplication tables up until year 4 at least, or certainly in year
Yeah.
4.
I remember before it came in, we were very much like the children need to have their times tables to enter year 6. Like,
Yeah,
let's just make sure they've got that before year 6, because otherwise year 6 is going to be so tricky. But if you think about the amount you need for fractions in year 5,
yeah.
actually, really, we do need it beforehand. They do
And
need most
multiplication
of
and
those.
division,
Yeah, of course.
fractions, multiplication, division, all those upper key stage 2 particularly, but I think probably year 4 onwards is so heavily weighted towards that multiplicative relationship rather than the additive one that you probably concentrated on since reception more heavily, that times tables just make all of that a lot easier to access, I think.
Yeah. Reducing the
So,
cognitive load, isn't it? That's what we're trying to do. It's not
yeah.
teaching by rote, but just, yeah, giving that shortcut to understand the other principles more deeply.
So I know some of the students there do listen to the podcast because I do give it a plug every time I'm there with them. So if they are listening, I will just say hello and thank you for all your work yesterday, and looking forward to coming back to division at the start of the next day, which is supposed to focus on fractions. So just division and fractions to cover in that day,
Just
Sally,
what in
which,
one day.
yeah,
Yeah,
a
easy.
walk in the park, a walk in the park. So that was fun. And then earlier this week, the University of Nottingham's Mathematical Education Observatory published their sort of State of the Union, their review of maths education in England. So I was reading through that as well. I've been writing a couple of articles based on their findings, and I pulled out a few headlines. Sally, if you want to have a quick sort of dive into that, because
Yeah,
it was
please
quite
do.
interesting what they found. We're, they've looked at education all the way through to degree level, I believe, but I focus very much on the primary side for us, dipping into key stage 3 a little bit. And some of the stuff that they found, I think, backs up kind of what we already know or what we imagine. So, for example, they found that reception children start their maths journey, if you like, feeling very confident and with a positive attitude generally towards maths, which is nice. In fact, they described it as overwhelmingly positive attitudes towards maths. Um, Although there's some variation that sort of emerged between schools, which was interesting, and also between months of birth as well. So depending on whereabouts in the year you were born, and I mean, we know, don't we, that it's a huge um, difference between a child that's born in September and a child like me, sadly, that was born in August.
So
Starting
the summer
starting
born
reception.
stuff.
Yeah, there's summer born children disadvantaged all our lives. But the, when you're 5 years old, that extra year is massive, isn't it?
It's huge.
Um,
I mean, we're still talking about when you're in early years, you're talking about their months of development, aren't you? Like you
yeah,
are when you've got toddlers doing sort of
yeah,
health
milestones every
activities
month, aren't you?
and things. Yeah. So, you go from that to thinking that, oh, of course, they're all going to be the same entering. They're just not. And you can see that, not with maths, but with like things like pencil grip and, the bones in their hands, the muscles in their hands just aren't developed as much. So, yeah, of course they're not all going to start on the same level there.
No.
And it's a real art form, trying to manage that.
But it was nice to hear that children are positive about maths when they start reception. We know that they are less positive about maths in secondary school, particularly, and that came out through the reports as well. So something happens between starting reception and starting secondary school, which I think we probably need to be aware of and focus on how we can improve those or keep those attitudes positive. In terms of teachers, they found that most primary teachers feel confident teaching maths, but they don't have enough time to prepare, in their opinion, not just for maths, I think, but for things in general. And again, that sort of takes me to other jurisdictions and things. When we look across to somewhere like Singapore, their maths teachers in primary school only teach maths, and they typically have the afternoon each day to plan the next session and catch up with any children that they need to. So, yeah, I can appreciate that, how teachers feel under the cosh a little bit when it comes to trying to find time to prepare all these fantastic
And I
lessons.
think you've just actually done a secondary point there, really, in that statement, is that they have time to catch up with those other children, where we've like ended up with hardly any teaching assistants, struggling
Yeah,
to, you're trying to cover the curriculum. You want to give you that teacher input into all of your curriculum. So if you're doing history in the afternoon, you don't want to just y- give them a holding task. You want to really input that knowledge, and yet you still need to try and either do your pre-teach or catch up
yeah.
some
When do
children if
those
they haven't
interventions
grasped the
happen?
concept.
Yeah.
So yeah, that's a key problem, isn't it, at the moment?
Yeah, and I spent a lot of years as a maths lead trying to figure out a solution to that. If anybody has a solution to it, we would love to know. Primary Maths Podcast at twinkl.co.uk, please, with your solutions to when do you actually find the time to support those children who might need a little bit of extra input before the next maths lesson, because I just think that is a key to cracking this, but I don't know that there are any easy answers, really. Um, Another interesting thing, which I sort of thought that I knew intuitively, just from experience and anecdotally, I suppose, more than intuitively, but was backed up by the findings here, is that most maths leads teach in year six, um, which is interesting, isn't it? I don't know necessarily why that is, but it seems to be borne out by by the findings of this report.
Yeah, I've definitely noticed that when I was a maths lead, I was sort of a bit different actually, because I taught year four mostly, and then I
Yeah.
actually went down to teaching early years. I've never taught year six. I've tutored in year six, but yeah, I think I was quite a bit of a unicorn
You're an
there, not the
outlier,
youngest
Sally.
teacher.
Yeah,
Yeah.
you're an outlier. Yeah, it's interesting. I've worked in my years working with dozens and dozens of maths leads. I worked with one maths lead that was based in nursery. Um, but other than that, I would say the majority in primary schools have been at least Key Stage 2 based.
Mhm.
Um, a few in Key Stage 1, but often in Key Stage 2. And I don't think it's necessarily a problem, but unsurprisingly, the research also found that those maths leads were less confident than with, for example, EYFS maths and what it looks like in EYFS. Um, which is where I will give another little plug actually to something that we produce. So I worked on a PD course that you can find at twinklpd. .com.co.uk, one or the other, or just Google Twinkl PD,
Probably both.
which is it's aimed at maths leads who want to know more about EYFS and how to support maths in early years. So if that is something that you're interested in, if you're a maths lead listening to this, and you perhaps have got more experience in Key Stage 2 than in early years, and you want to know a bit more, that's one place that you could go to find out a little bit more. The other place that you could go, of course, if your school has it, is the early years classroom, and that's where because I was always, Sally, a little bit scared of early years. It was, behind a door in the school that I didn't venture through very often. There were small
Yeah,
people in
so
there that were a bit sticky, often, and
coming towards you.
yeah, yeah, yeah. Always delighted to see you. Always
Yeah.
delighted to see you. Always very curious. Covered in glitter and other substances. But do you know what? When I actually got over myself and spent some time in there, it's just a great place to be. And I would encourage anybody, if you've got early years in your school and you're less familiar with it, go and spend some time in there because it's a great place to be.
I love being in early years. I was 3 months into being a maths lead when Ofsted called and did a deep dive into maths. So,
Wow,
in at the deep
you being
end.
appointed maths lead triggered an Ofsted inspection. Is that what we're
Yeah,
saying?
they were like, "Oh, better go check."
What's going on here?
Yeah,
The schools,
yeah.
yeah,
So, and I thought, "Oh, I'd be handheld by SLT through it," and they were like, "No, it's just you and the inspector." And I was really honest with him. I said, "Look, I've only just become maths lead. I've focused on Key Stage 2. I'm in Key Stage 2." Um, and he said, "Right, okay, well, we'll use this as a training experience." And he, I know we fear Ofsted, but actually this Ofsted inspector was really supportive of my career. And he said, like, "This is what I'm looking at. You tell me what you can see." And it was
yeah.
such a great, it was great professional development for me, actually. And and then I wanted to know more about early years from that point. So yeah, I went down the following year and taught in reception. But yeah, it was really actually a positive experience, my Ofsted inspection.
Wouldn't it be lovely if Ofsted was a little bit more a little bit more in that way of professional development as well as evaluation? That'd be lovely. I think that's kind of how the model used to be before Ofsted came in. You'd have local inspectors that would have a relationship with the school that would come and support teachers a little bit more.
Mm.
So yeah, I know there's all sorts of reasons why that might not be the case at the moment, but it seems like a great model to me in my limited experience. Um, so yeah, a couple of other points from this report as well. I'm not going to go through it in depth, but there was a couple of other things, particularly around the journey through primary and into secondary. So, for example, they found that 2 in 5 Year 7 pupils report high or somewhat high maths anxiety. 2 in 5. I mean, that's a huge number, isn't it?
Well, yeah.
Um, and obviously that's not just we've started year 7 and now we've got maths anxiety or anxiety about maths. That obviously starts in primary school, and we know that children generally start feeling very positive about maths and reception. So something is happening in primary school that we need to be aware of. The big attainment gaps that we see at GCSE, that they are already forming at primary, and they tend to stay all the way through. There's very little movement they found in gaps that are associated with socioeconomic backgrounds and disadvantage. And we find that children's outcomes at Key Stage 2 are incredibly predictive of whether they'll go on to further maths or A-level maths or anything like that. And so clearly, what we are doing in primary schools has a huge long-term impact on those children. So that's something just to be aware of, I suppose, as well. Continuing with the secondary theme, they also found that Key Stage 3 is still sort of a mixed bag, a lot of variation between schools in terms of how much impact Key Stage 3 has. And so again, there's more sort of pressure on Key Stage 2, particularly to make sure that children are well prepared for secondary.
And the
Um,
critical assessment review said that as well, didn't it? That
they
Key
did,
Stage 3
yeah,
tended to be a lot of repetition of Key Stage 2, and that
yeah,
maybe it should be a more structured sequence.
yeah. I love that idea of having seeing Key Stage early years, Key Stage 1, Key Stage 2, and Key Stage 3 as a continual sequence of learning all the way through, and then
Sounds quite
obviously
logical.
when it makes sense, doesn't it? It doesn't. I'm not sure why it doesn't feel like that at the moment, but it doesn't feel very joined up at the moment. And obviously, Key Stage 4 is a slightly different bag when you've got GCSEs looming and things and different papers and therefore slightly different syllabus. But for all the way up to the end of Key Stage 3, I don't see why there isn't a bit more joined up thinking. So, yeah, it was a really interesting report. There was a little bit on gender differences and how they appear quite early as well. So, I think all in all, even though I've just said that there are issues, there were lots of positives that came out of it in terms of the state of maths education. It's just that there are obviously things that we still need to work on, and you know, that's one of the reasons that we're doing this podcast, Sally, so we can spread the good word about the good stuff that's happening and the even better ifs, I guess.
Yeah.
So I have got a maths of life for you, but I'm slightly worried that it might bring back some traumatic memories and experiences of a previous episode, Sally, that you
Oh, go
appeared on.
on. Come on, John.
Where, well, earlier this week, I'm sure you saw a certain Elon Musk was awarded in my opinion, just my personal opinion, a frankly ludicrous pay deal. Did you see how much he was given by Tesla?
Was it a billion or a trillion?
It was $1 trillion. It was $1
A
trillion.
trillion.
Yeah, we already did
Okay.
the billion. We already did how big's a billion. So I thought, well, we've done how big is a billion, and I thought, okay, well, he's been awarded a $1 trillion now. So how big is $1 trillion? Now, I'm not going to ask you any questions this time.
No, please don't, because I'm writing down on a bit of paper. I'm trying to think of how many zeros I'm at.
Yeah. Well, I'll tell you. How many did you write down?
No, I'm not there yet.
No. Okay. Well, it's $1 trillion is a 1 followed by 12 zeros.
Right.
I'm not doing this off the top of my head. I did write this down earlier, so I have that advantage over you, I'm afraid. And it follows the sort of normal pattern of ones, tens, hundreds, and then the next family. So it's 1,000 times bigger than a billion. It's 1,000 billion. The new model, we'll call it, of $1 trillion. It's not really a new model, but it's newer in this country. So up until I think it was 1974, the UK originally used the long scale, where a billion was a million million,
Yeah.
and $1 trillion was a million billion. In which
Not a
case,
billion
in the
billion.
old, sorry.
It would be more logical if it was a billion billion, wouldn't it?
Yeah, it's weird, isn't it? I mean, to me, it makes more sense that it's 1,000 million because of those families of
Yeah.
numbers as you go through. It follows the same pattern. But it used to be in the long scale, $1 trillion would be a 1 with 18 zeros, whereas now it's a 1 with 12 zeros. So that was up until 1974. The government officially adopted the short scale, which matched the American version. And for once, I agree with, I think the American version makes more sense. But yeah, if you're talking to somebody pre 1974, they might think that $1 trillion is even larger. Although I think it's big enough as it is. So if you were to spend £1 million every single day and not earn any interest on it, £1 trillion would take you 2,740 years spending £1 million a day to spend all of that money. So I reckon Elon is probably okay for for pocket change for the rest of his life. If you earned £1 a second, or you wanted to count $1 trillion up to $1 trillion, and you counted one number per second, I don't know if you can remember how long it took to
I'm trying to
count
think where we were
the
before.
billion. Yeah, so $1 million would take you 11 and a half days, right?
Right.
$1 billion would take you 31 years.
I think I might have heard
Trillion.
this. I'm thinking
Well,
we're
we know.
going before Common Era.
Yeah, so I mean, if you think about it, we've already said $1 trillion is 1,000 times bigger than $1 billion. So if it takes 31 years to count, or to count to $1 billion in seconds, 1 billion seconds is 31.7 years. Then $1 trillion seconds is going to be 31,709 years, which is quite a long time, and definitely before Common Era, as you say. Which is just a ludicrous sum. However, not everything that's $1 trillion is that big. So 1 trillion grains of sand would be contained in quite a small bucket. So,
Wow.
not everything that's a trillion is huge. Um, I know that your favourite method of measuring things, particularly volume, is in cornflakes. That's right, isn't it?
Yeah,
So
cornflake
always
crunching.
going
Yeah.
on about
Yeah.
how many cornflakes is that? Well, a trillion cornflakes would fill 55 Olympic swimming pools. Another one of your favourite units of measurement. So yeah,
Wow.
a trillion cornflakes would fill. You need a lot of milk for that as well, wouldn't you? A lot of milk.
Yeah. My
Um,
daughter's
um,
eaten a lot of cereal this morning, but I don't think she'd get through that.
yeah, I mean, kids. Yeah, I've got a daughter that it seems a bottomless pit when it comes to cereal. It's incredible. But you would need a lot of milk, and for that milk, obviously, unless you were going to get it all from um, vegan sources, you would need a lot of cows and a lot of grass to feed those cows. So a trillion blades of grass. You see how I got there, Sally? It's
That was
impressive
tenuous, but you got there.
linking. Yeah, yeah, yeah. A trillion blades of grass would cover Wales about 12 times over, apparently, which is,
Wow.
impressive. I know Wales isn't that big, but again, it's another standard unit of measurement. Um, So yeah, last couple for you. A trillion printed A4 sheets. If you stood them on top of each other, they'd go. They'd make a tower 100 kilometers tall. And there are roughly 3 trillion trees on the planet. So yeah. So
Only
we've
three
got a
trillion
budget coming up
trees.
as only 3 trillion, yeah. But they are quite large. They're a lot larger than like a bucket, a grain of sand, aren't they?
I know, but Elon Musk having $1 trillion, well, just gifted to him, he's
Yeah.
already got more money than that, and that doesn't seem like the right.
Earned, Sally.
Oh,
Earned. He's
sorry,
earned every
earned.
cent of
Yeah,
that.
yes. Sorry. Yes, of course,
Yeah.
Sir
Yeah.
Elon.
Yeah. Yeah. Well done. Well done, Elon. A trillion, yeah, $1 trillion. Um,
It doesn't seem the right balance,
it's
does it? Trees to amount of
no,
wealth there.
it's mind-boggling,
Not a
isn't it?
right ratio,
And
yeah.
but it is interesting how much bigger than a billion. We've got a budget coming up as we're recording this, and there will doubtless be lots of numbers thrown around, millions and billions, maybe trillions. I don't know. Probably not trillions, but it's just incredible. These numbers become part of our everyday language, and yet when you actually stop to think about the scale of them, it's just mind-boggling. So yeah, I had lots of fun trying to find out how big a trillion was. And yeah, hopefully it was interesting for people, and if not, I still had fun, so not too worried. So earlier this week, I was delighted to be joined by the wonderful John B, who is a maths educator, recently written a book on maths education, and we had a great conversation for about 40 minutes on variation theory and task design. And I just wondered, Sally, if we could have a quick chat about some of the key takeaways from that episode, just in case anybody missed it or they want to go back and listen to it in a bit more depth.
Yeah, I mean, we know that variation theory is really, really important, right? And it's one of those key concepts um, for teaching for mastery. I think it's something that can easily be missed, and that's what you were talking about, wasn't it, with John? Um, I think one thing that I picked up on that he was saying, I really liked it, was because he was sort of using the 3 times 5 and then building on it. And I was like, okay, yeah, I've heard this before. And then I liked how he threw in that procedural shock where he like
So
mixed
go
it
on, give
up.
me the example. It was a couple of weeks ago. I spoke to him. Sally, remind me.
Yeah, so he was saying if you would and this is procedural variation here, so not
Yeah,
conceptual but procedural. He was talking about I would give 5 times 3, then move on to 3 times 5, so sort of
yeah,
showing the commutativity there, and then I might sort of bring in scaling, so I might do 50 times 3. um,
yeah,
and then he said the procedural shock, so I thought he was going to go, of 30 times 5 or 500 times
Yeah.
3, building upon that concept. But he then said he'll do a procedural shock there and actually might move it into a different area. So we're using the knowledge that we've built there, that we can use our scaling, but then go 3 times 0.5, 3 times a
Yeah.
half, and then use that to introduce multiplying by a fraction, which I thought, oh, okay, that's not where I thought he was going. He shocked me there, but I thought, oh, that was a really interesting, not just, okay, let's go A to B, B to C. Actually, let's do a bit of a bigger jump, get the basics down, and then reveal something else. So I thought that was interesting.
Yeah, and totally agree. And the great thing about variation is what it can draw attention to and make sure that conceptual understanding, even through procedural variation, can still add to conceptual understanding. So, funnily enough, I was working with the skit students yesterday who were brilliant, really engaged. And we were looking at what does it mean if you do 3 times a quarter? Because that's a really abstract concept, isn't it? Written down 3 times 1/4 looks really odd. If you've not, and there's a temptation to say, well, there's a procedure that we can follow here, and we could, we were getting a bit hung up on, do you do the same to the top as you do to the bottom, and do you multiply the numerator and the denominator, or do you just multiply the denominator, or all that sort of thing? When you actually take it back and you have opportunity to think about what it means, and if we've done enough work that we've got a really sound understanding that multiplication is essentially shorthand for repeated addition, and it's just repeated addition, and you can replace the time symbol with either of or lots of or something like that, and just really think about it, then it becomes really easy to see that 3 times a quarter is just 3 quarters, 1/4, another quarter, and another quarter, and maths becomes much easier than just trying to remember lots of procedures. Um, and so I think variation is such a wonderful way of drawing attention to these things and showing what something is and what something isn't, so that you've got that deeper conceptual understanding, and therefore it enables you to do easier maths than potentially you would do if you were just trying to boil maths down into a list of procedures and rote memorization of things.
Yeah, and I think that's how children stay on board with the maths. For me, I was all right at maths at school, and then I got to A level, and it was so abstract, and I just lost the grasp of it. I didn't know what the point of what we were doing was, and I just, yeah, I was completely lost and dropped out because it just became so abstract. So it's really important to make sure that we're sort of bringing it down into those. I mean, yeah, you're talking there about, yeah, just really that conceptual understanding of what
Well,
we're doing
I
with.
think what you've just said there, Sally, is so important. And I think that happens to almost everybody at some point in terms of the maths just becomes too abstract. But for some people, that happens in Key Stage 1. For some people,
Yeah,
that happens in Key Stage 2. For others, GCSE, and for other people, A-level or degree maths. At some point, you lose the meaning of what's actually happening in the maths, and it just becomes symbols and numbers and things, and you're not sure where they've come from, or like you said, what the point of them is.
yeah,
And so the longer we can help children hold on to actually what these things really mean, rather than just seeing them as abstract concepts, the longer we can keep them engaged, I think, and keep them thinking, which is clearly the point, surely. I think it's just important, as we've done a lot of work on variation, as you say, over the years, and as you say, all good schemes have got variation kind of built into them. I think what can be dangerous is when we start to confuse variation with variety, and just having lots of different ways of seeing something for the sake of having lots of different ways of seeing something. Because variation is not the same as variety, and just having lots of different examples or loads of representations isn't necessarily a good thing unless there is a real purpose for those, and you as a teacher are aware of what you're trying to get children to notice by having lots of different examples of the same thing. So, we're trying to highlight the essential and the non-essential features of a particular concept. You might need a couple of different representations to do that, or a couple of different procedures to do that, or whatever. But if we introduce way too many, it can just muddy the waters, I think. So I think John made a good point about, and it's something that we've said quite a lot, isn't it? About, the scheme is the starting point. It gives you a really good starting point, but you as the class teacher, you need to make those choices about how you're going to actually use this with your class of children in their specific moment in time, knowing them and their skills and their knowledge, and make those decisions about, which representations you're going to use, which methods you're going to use, making sure it's consistent with the rest of school, but having that awareness that if we just throw too much at children, it undermines actually the purpose of the variation, which is to draw attention to one thing, and can just become confusing instead.
Yeah, I went to a session actually run by Pete Mattock, our secondary thought leader, on Tuesday, I think it was. It was the International Maths Conference, and he did
Oh yeah,
he did a session all about how to build schema, and he was just showing actually how you can use the ratio chart for showing scaling, but how that can be. He went from like showing how you can use it to understand a pictogram, so understand what the shapes on the pictogram represented when they don't just represent one, but they're used for scaling. And then he moved that on to sort of key stage 4 algebra. And it was just he showed lots of different ways that you would model or solve a problem by, that's the problem. There was like pie charts, loads of different ways that problem could be shown to you. But actually, if you've got one representation that you go back to model it in, it can be used in so many different ways, and actually a really powerful representation. So I thought that was really interesting, showing how that can move from like early key stage 2 right through into key stage 4, because you've just used one representation that you've used consistently and built that up. And
yeah,
that's where, when we were talking about how actually it's really important that key stage 3 follows on from key stage 2, it's actually talking about those representations as well, isn't it?
yeah,
We're using we start using might start using a bar model in key stage 1, and we build on that going up. And same with the ratio chart, we start that at the beginning of key stage 2 and then build that as you go up, and you can use it, and then that problem solving becomes so much easier. It was a really interesting session. I think that was sort of being brought on by that point as well.
yeah. Just using things thoughtfully and attending to the inbuilt variation, not changing too many things at once, having a purpose for why you're doing what you're doing. It's these sorts of things that it comes back to, and just being really clear on what you want the children to notice by doing these different things. I think it's as simple as that, but it can be, you say it's as simple as that, it can be easy to lose sight of that when you've got, maths is one of your lessons of 5 that you're planning today and that you've got to deliver, and that you're doing it without a teaching assistant, and you're doing it with 30 kids, all those things that we know teachers um, have to manage day in, day out. We're sitting here just talking about maths because that's the only thing we've got to think about. But I know that's not the reality. But sometimes just keeping it simple, and just having a really definite focus on one area can be really helpful. And so sometimes when we talk about variation, I think we get caught up with this idea that it means lots of different things, but actually it really just means often keeping things the same and just changing one small thing, a bit like a science experiment, really, and revealing something through doing that. So if you do want to hear any more about variation theory, definitely go back and have a listen to John's episode. It was episode 31 of the Primary Maths podcast that was released on Tuesday this week. But Sally, I think that is probably enough for today. We've covered quite a lot. We've covered the state of maths education. We've covered how big a trillion is, and we've thought a little bit about variation theory. I think that's. I need a weekend now. So thank you very much, Sally, for joining us again. For everybody else, we'll be back on Tuesday with another interview episode. This week we are speaking to Phil Hurd, and we're going to be talking all about problem solving and the potential problems with problem solving. I'm sure we'll solve all of those in that 40-minute chat. So join us again on Tuesday. Myself and hopefully Becky will be back next Friday with another AfterMaths episode. In the meantime, have a great week. Thanks again, Sally, and I will say goodbye from me.
And goodbye from me. Thank you for having me.
No worries. Thank you. Have a good week.